Hello everyone and welcome back to Tech with NK. In this video, we're going to go through an intro to data visualization with Python. We're going to see how to analyze trends, compare categories, and visualize patterns in our data. And to do this, we're going to go through how to set up an environment, ensuring that we have all the right libraries, and then we're going to see how to make plots with Matplotlib and Seaborn. We're going to look at the plot and subplots functions of Matplotlibs that enable us to make plots. And also we're going to look at the line plots, bar plots, and scatter plot functions of Seaborn using real-world data available to the Seaborn library. And if you stick with me to the end of this video, you're going to learn how to create visualizations and understand what they reveal about your data. So if that gets you excited, get ready and let's dive right into it. So like with our previous videos, the one on NumPy and Pandas, link in the description of this one, the first thing we need to do is to set up our environment right. To do this, we need to install the libraries, Pandas, Seaborn, and Matplotlib, which we're going to use for this video. If you do not have these libraries installed yet, you could just run this code cell here and it's going to do the job for you. But I already have these libraries installed, so I'm going to skip this. And I'm just going to come around this code cell here where I'm importing the necessary libraries. Importing Pandas as PD, Matplotlib.pyplot as PLT, and Seaborn as SNS. Those are just standards. And like we said, we're going to start with Matplotlib, looking at the function plot. And the first kind of plot we're going to look at is the line plot. And to display this, I'm just going to generate some fictional data here. I'm going to create an array or call this X. And in this array, I'm just going to pass in some fictional values. Let's say 1, 2, 3, 4, and 5. And I'm going to create a second one or call this Y. You can look at it as our X and Y axis. And I'm going to put in some fictional data as well. 2, 4, 6, 8, and 10. And to generate a line plot using these two arrays with Matplotlib, it's very easy. All you need to do is run plt.plot. And in parentheses, we're going to pass our x-axis as x and our y-axis y for our two variables x and y that we just had here. And before running this code cell, we're going to display a plot. To do that, we're going to run plt.show, open and close parentheses. And if I run this code cell, and as you can see, we have our line plot right here. And one reason why Matplotlib is used by many today is because it's very customizable. So we can add a lot of customizations to our plot as we have it right here. As it is, it's very simple, very basic. There's not a lot to it. But let's say we want to add like labels to our plot, like an x-axis label or y-axis label or a title. There are functions to help us do that in our Matplotlib library. So let's say the first thing we want to add is the title. That will be plt.title. The names are quite explicit, and let's put as a title line plot. And with this title, let's say we want to add an x-axis, so that will be plt.x label, and in parentheses we're going to give it a string label that will be x-axis. And we can do this as well with the y-axis. If I copy and paste this here, let me just modify this x and put as a y, and this other x here and put a y. And if I run this code cell now, we see our labels have been displayed. We have a line plot as our title, our y-axis, and x-axis. And this is just the tip of the iceberg, because there are a lot more customizations we could add to this plot. For example, let's say we want to modify our ticks. What are ticks here? Our ticks are these values you see here. Like you have 1, 1.5, 2. These are like the x ticks, and here we have our y ticks. And it's a common practice when making your plots to modify these values, probably to suit your specific use case. And with Matplotlib, there are functions to help us do this very easily. The functions as well are quite explicit. We have x ticks and y ticks. Let's say we want to play with our x ticks first, so we have plt.x ticks, and in parentheses. In this case, we see that by default, our graph has like 1, 1.5, 2, 2.5. So the step is like a 0.5 step. But let's say we want the exact values like our list here. So I'm just going to pass that to our s6 here, pass the variable x. And if I run this, We see our x ticks have been modified. We have now 1, 2, 3, 4, and 5. And we don't have that step in between. We can modify the y ticks as well. If I copy and paste this here, Control C, Control V, and here I modify this to be y ticks. And for the y ticks, as we see our ticks presently, we see they start from 2 to 10. But let's say we want to change this to start from 0 all the way to 10. To do that, I'm going to remove this x here, and like with the x ticks, we need to pass an array-like parameter. And for this case, if we want to start from 0 all the way to 10, we can use like a range function to generate these values. So I'm just going to call our range function, and in parentheses, I'm going to pass 11 because I know this is going to generate values from 0 to 10. And if I run this code cell now, we see our graph has changed again, and our y ticks start from 0 all the way to 10. Our x ticks 1, 2, 3, 4, and 5. And now let's move on to our bar chart. For our bar chart as well, I'm going to create some fictional data here. Let's create a variable, we'll call it categories. And in this variable, we're going to pass an array-like parameter as well, or list if you prefer. And we're going to give it the elements A, B, next one will be C, and we're going to give it the last one D to represent 4 separate categories, and we're going to give these categories values. So I'm going to create a second variable here, and in another list I'm just going to fill in some random values, let's say 5, 7, 4, and 9. And to generate our bar chart, all we need to do is to call plt.bar, and we're going to give it the parameters categories and values. And if I run that, as we can see, we have our bar chart displayed on the screen. And as you just noticed, it's possible for us to display our charts without using plt.show. And our chart is quite simple. It has no X label, no Y label, no title. But by now, I'm sure you already have all the tools to add this by yourself. So we're just going to move on to the histogram. And we're going to create another fictional list here. We're going to give it a few parameters. Let's say we have 1, 2, 2, 3, 3, 3, 4, 4, and 5. And to display our histogram, we're going to use a plt.hist function, which takes a few more parameters than our previous functions. The first, our array-like parameter, we're going to pass our data. And for our bins, we're going to pass a parameter, say 5. And if I run this code cell, as we can see, we have our histogram displayed on our screens. And we have this extra data here because we didn't include plt.show. But if I add that, we see this is going to disappear. So plt.show, and I'll run this. And now we have our plot only. And with this, I hope you have an idea of how to create basic plots with Matplotlibs. There are a lot more customizations we could add to this plot, but we're going to keep that for our next section on Seaborn. However, before we get to Seaborn, we're going to look at the Matplotlib function called Subplots. And as the name entails, the Subplots function is used when you want to have like subplots in one big figure. And it's going to make a lot more sense with an example. So to do this, we're going to create two variables here, fig and axis. And we're going to set it to plt.subplots. In parentheses here, we're going to pass in two parameters, the number of rows and the number of columns. In this case, I'm going to pass 2 and 2 for each. Now, if I run this, just for you to see what it looks like, we see we have one main figure, which is all of these here, and then we have subplots, subplot 1, 2, 3, and 4, which can be accessed using this variable axis here. And you can think of our axis here just like an array, where this first plot here will be position 0, 0, the second plot here will be position 0, 1, this third plot here will be position 1, 0, and this plot here will be position 1, 1. As it stands, our plots are empty, but let's say we want to put these plots that we just did here in the spaces we have below. It's very easy. All we need to do is, let's say we copy this line of code here, Control C, we come back down here, and we're going to add a first plot here. If I paste this here, and instead of plot, I'm going to put axis. And remember we said the axis here is like an array, And if we want to plot our line plot, say in this first position here, I'm going to pass in square brackets 0, 0 for row 0, column 0. And if I run this code cell, we can see we have our line plot. And we're going to do the same for this plot and this plot. So if we scroll back to the top here, we're going to take this second line or this third line here, and we'll come back down and paste it right about here. Modify this should not be plot but axis, and the position 0, 1. Run this code cell, we can see we have our bar chart. Same thing for the histogram, we can copy this line here, and if we paste it down right about here, let me remove these empty spaces, they are not necessary. And instead of plot here, we want to access the axis in square brackets, position 1, 0. And we run this, we have our plots just like we had before. And for this last space, there are two things in my mind that we could do here. We could either repeat one of these plots here, probably in this position. All we need to do is just modify our location parameters here. Instead of probably say 1, 0, we put like a 1, 1. It's going to repeat the plot, the histogram here and here. Or another thing we could do, let's say we do not want another plot here, we could actually remove this plot. And right now I'm in favor of removing this last plot here. And to do that, we're going to run our axis, set the position 1, 1, and we're going to call the function remove. And before running this, I'm going to add a line plt.show, and let me run this code cell now. We see we have our 3 plots and the last one has been removed. And with this, you already have a good idea of how to make plots with Matplotlib. Next, we're going to move to Seaborn. And like I promised in the intro of this video, I said we're going to use some real data in the Seaborn library. We're going to use a common data set available to the Seaborn library called tips. So I'm going to create a variable here. I'm just going to call that variable tips. And I'm going to call sns.load_dataset. And we're going to pass the parameter tips. Now if I run this code cell, this runs successfully, meaning our data set has been loaded. Now in another code cell here, let's run tips and see what it looks like. And as we can see, we have our first 5 values and last 5 values here. Well, the tip data set is a very simple one. It has 244 rows and 7 columns with the headings total bill, the tip, sex, smoker, day, time, and size. And you can think of these as data from a restaurant where the total bill represents the bill of a customer, the tip represents the tip they left at the end of their meal, the sex here represents whether they are male or female, smoker here has values no and yes for smokers and non-smokers, the days here represents the days of the week, in this case Sunday, Saturday, Friday, and Thursday. And the time tells us 2 things, whether the customers had dinner or they had lunch. And the size represents the table size, whether there were 2, 3, 4, and this goes up to 6. So now we have an idea of what our data looks like. And next, we're going to use a few plots here to try to obtain patterns or meaningful information for our restaurant. And the first thing we want to know here is, how does the total bill vary with the table size? And we're going to use a line plot to display that. So we're going to call the line plot function in Seaborn. That will be sns.lineplot. And in parentheses, the first thing we're going to do is to tell Seaborn what data we're using to make this plot. So we're going to set the data parameter to our tips. Next, we're going to set our x and y axis. Our x-axis we're going to set to the table size. And our y-axis we're going to set to the total bill. That will be total_bill. And if I run this, we see that this works, and we have our line graph showing us the relationship between the table size and the total bill. And by default, Seaborn used the x-axis and y-axis parameters we pass here to label our x-axis and our y-axis. However, our plot has no title, but the fix for this is very easy. And what I want you to note is the Seaborn library was built on top of Matplotlib. So it's possible for us to use our Matplotlib functions to customize our Seaborn plots. So like we saw before, if we wanted to add a title using our Matplotlib functions, we're going to use plt.title and we're going to pass a title to it. In this case, I'm going to set our title to average total bill per table size. And also we can display this with plt.show. And if I run this code cell now, we have our title, average table bill per table size, and we have our y-axis label, our x-axis label, and our line plot. And if you're wondering why we have this margin here, this is called a confidence interval. The reason why we have this is, by default, when we are making a line plot of our size against a table bill, Seaborn applies the main function on our values to generate an average which it uses to make this plot. And pretty much what this means is to get this point here for the table size of 2 people, Seaborn takes all the total bills for table size 2, calculates the mean, and then uses that to plot this point. Same thing for the table size of 3, 4, 5, and 6. And so this range here gives us an estimate of where the actual values will lie. But if we do not want it and we want just the line, there's a parameter that we can modify here called the error bar, and we can set this to none. And if I run this, we have our line plot without the confidence interval. And note that by default, Seaborn applies the main function on our values, but we could change this and choose to apply any function of our choice, be it on median, be it on mode, or a function we defined by ourselves. So I think with these we're good with the line plot, and next we're going to move to our bar plot. And what I want you to note is bar plots in general are used to show comparisons between categorical data. And one example of this is we're going to compare our tip amount across the various days of the week, of which the days of the week here represent our categories, and our tip amount, the data we want to visualize over these categories. And the code for this is quite simple. All we need to run is sns.barplot, and we'll pass our parameters like we did before. The first parameter is our data. We'll set it to tips. Next, we're going to pass our x-axis like we always need to, and we're going to set our x-axis to day, which is the name of the column that has the days of the weeks. And for our y-axis, we're going to pass our tips. And we could add a title to this, but I'm going to skip that and just display our plot with plt.show. And when I run that code cell, we have our bar plot with our tips against the days of the week. And just like with the line plot, our bar plot gives us an average of the tips per day. So on Thursdays, the tip average is somewhere between $2.5 and $3. On Fridays, pretty much the same thing. On Saturdays, we have it somewhere at $3. And on Sundays, we have it somewhere between $3 and $3.5. And like we just said, our bar plots in general are used to show comparisons between categories. And this bar plot function comes with a few parameters that can help us display many more categories, as you can see here on my screen. And one of these parameters I want to use here is called the hue, and I'm going to set this to one more category, let's say the time of the day. And if I run this code cell, we see our plot has changed a little bit. We have our legend below here that tells us that the blue plots represent lunchtime and the orange plots represent dinner time. And with this plot, we could actually draw a lot more information from our data. And we see that on Thursdays, people tip more at dinner compared to lunch. Same thing for Fridays. On Thursdays, the difference is not so much, but on Friday, we see that the difference is quite bigger. And on Saturdays and Sundays, we see that we have 0 tips during lunchtime. And one more thing I realized from this data is if we modify our y-axis here, and instead of the tips, we're displaying our total bills, and I run this code cell. And what I want us to see is that for Saturday and Sunday, the bill at lunchtime is 0, which means you have no customers coming in to eat at lunch. And if you're the manager of this restaurant and you're presented with this data, you want to figure out like, why do you not have customers at lunch and you only have customers during dinner time on Saturdays and Sundays? Should the restaurant be closed at lunch and open only for dinner? What could we do to draw in customers during lunchtime so we do not have like 0 sales at lunch? So there are a lot of things that you could think about having this data presented to you. And with these, we can see how powerful visualizations can be. And the last but not the least, we're going to look at scatter plots. And what you need to know is, in general, scatter plots are used to display relationships between two numerical variables and highlight patterns between these variables. And for example, we're going to analyze the relationship between our total bill and our tip amount. So do people who spend more on food tip more? Let's find out. And to do this, we're going to run like usual SNS dot. The function is called scatterplot. We're going to pass in our data like we've seen before, which is tips. We're going to pass our x-axis. In this case, it's going to be the total bill, and our y-axis, in this case, the tip. And we're going to display our plot plt.show. And if I run this code cell, we can see we have our scatter plot. And each of these dots here represent a unique cell. And from the looks of it, we see that when the total bill increases, moving to the right, we have our tip also increasing, moving upwards. And you can clearly see the inclination of these dots, telling you that as the total bill increases, yes, the tip actually increases. So people who spend more on food do tip more. However, when we look at data, we see there are many more categories we could play with. Like we have like the time, be it dinner or lunch, we have the table size, and we may want to figure out, does the table size matter? Like if we have a table of 6 people, would they tip more than a table of 2 people? Or if we have like smokers, do smokers tip more than non-smokers? And we could actually add these customizations using some parameters available to us in our scatter plot. And the first parameter we're going to add here, like we saw before, will be our hue value. And we're going to set this to the day. And if I run this code cell, we have a legend here that tells us that the blue colors represent Thursdays, the orange Fridays, the green Saturday, and the red Sundays. And from the distribution of the points, like you can see here, we have different colors almost around everywhere, like the red, green, blue, and orange just spread out here. And what if we change this, and instead of the days, we wanted to see how this changes with be it the smokers or non-smokers. And if I run this code cell, we have the smokers with blue and the non-smokers in orange colors. And for the most part, the points are kind of spread out a little everywhere, the blue and orange points. And probably with a different kind of plot, maybe the bar plot, where we can display that the average of these tips, we'll be able to get a better difference between the smokers and the non-smokers. But I'm just going to remove this and leave it to days. Run this again. We have our days like we had here. And one more parameter I'm going to add here will be the style. And I'm going to set this to time. And if I run this code cell, when we look at our legend, the colors remain the same. Blue for Thursdays, orange for Fridays, green for Saturdays, red for Sundays. That's for the days. And for the time, the dots represents lunch and the X represents dinner. And we can look at our points again and try to figure out what this means. Well, that said, we've come to the end of our video. I hope you enjoyed it thus far. If you have any questions or any challenges, feel free to leave them in the comment section of this video and I'll be more than pleased to answer you. However, I want to believe I did my best to make the video as easy and understandable as possible. If you did enjoy the video, do well to hit the like and subscribe buttons, and I look forward to seeing you in my upcoming videos. That's it. Have a good day.